You have probably used a microwave thousands of times to warm leftovers, melt butter, or make popcorn. But have you ever wondered why it sometimes hits unevenly, or why metal spark, or even why two grapes can create a tiny lightning show right inside your kitchen? To find out, let's uncover the story of how microwaves were discovered by accident and how this invisible energy became one of the most fascinating pieces of technology in your home. Our story begins in 1945 with an engineer named Percy Spencer who worked at Raytheon, a company building radar system during World War II. While testing a magnetron, a device that produced high-frequency microwaves for radar, Spencer noticed something strange. A candy bar in his pocket had melted. Intrigued enough, he placed popcorn kernels near the magnetron and they popped. Then he tried an egg, which heated so quickly it exploded. That's when Spencer realized these invisible waves could cook food. He filed a patent in late 1945, and by 1947, Raytheon introduced the first commercial microwave oven, the radar range. It was taller than a person, weighed over 300 kilograms, and cost thousands of dollars. Used mostly in restaurants and ships, not homes. But it was the beginning of kitchen revolution. So, what really happens inside that humming box on your counter? Microwaves are type of electromagnetic waves just like radio waves, only much shorter in wavelength. Most home ovens operate at a frequency of 2.45 GHz, which means electric field inside them flips direction about 2.45 billion times per second. Now here's where water comes in. Water molecules are polar. One end is slightly positive, that is hydrogen. The other is slightly negative, that is oxygen. When exposed to an oscillating electromagnetic field, these molecules try to keep up, rotating back and forth billions of times per second. That constant motion creates friction and collision with neighboring molecules, turning microwave energy into heat. This process is called dielectric heating, and this warms your food from inside out. But if that's how microwave work, why does your soup heat evenly while your pizza comes out half cold? That's because microwave interacts differently depending on water content, structure, and mobility of molecules. Liquids like water, milk also heat evenly because their molecules move freely and spread heat quickly. Moist food like vegetables, meat, and pasta absorb microwave efficiently. Dry foods like cracker, chip, or rice don't heat well. They simply don't have enough polar molecules to absorb the energy. And frozen food? The ice locks water molecule in place, preventing them from rotating easily, which leads to uneven heating. That's why thawing food first gives better result. The microwave can move through water much more efficiently than ice. Now, let's talk about one of the coolest and most viral experiments, the grape plasma. When you place two grape halves close together in a microwave, something incredible happens. A bright, glowing ball of light appears for a split second. Here's what's going on. Grapes are mostly water, so they absorb microwave energy very efficiently. At the point where two halves nearly touch, the electric field gets extremely concentrated, creating a hot spot in the air gap. The field becomes so strong that it ionizes the air, which knocks electrons out of gas molecules, and that forms plasma, a glowing mix of charged particles. High-speed cameras and thermal imaging have shown that this hotspot absorbs microwave energy even more intensely once plasma forms, sustaining that tiny glowing sphere for a moment before it fades. It's basically a lightning in miniature right on your plate. Now, if grapes can make lightning, what about metal object? Metals contains free electrons that move easily. When microwaves hit metal, those electrons rearrange to cancel the field inside, causing microwaves to reflect instead of pass through. That reflection alone isn't dangerous, but at sharp edges, thin points, or crumpled foil, electrons crowd together, creating an intense electric fields. Those fields can ionize the air nearby, producing sparks or arcs of plasma, the same kind of effect in grape experiment. That's why microwave manuals warns against metal container or foil, not because the oven will explode, but because you could create a miniature lightning storm in your dinner. It's amazing to think that every time you press start, your microwave is shaking water molecules billions of times per second, creating enough chaos to heat food or even to make sparks fly. From Percy Spencer's melted candy bar in 1945 to a plasma-filled grape experiment today, the microwave story is a perfect example of how accident, curiosity, and science can change the world. If you're interested in watching the grape video Creating Plasma, I have provided a link down below, a video created by Veritasium. And if you enjoy this dive into everyday science, hit like, subscribe, and tell me what mystery you want to explore next. Until then, stay curious.